In 2009, John Deere introduced a machine built to do the work of both a motor grader and a crawler dozer, the 764 HSD. Articulated steering, independently suspended rubber tracks, and cab-forward sightlines, all integrated into one hybrid earth-moving platform. Within a few years, it was gone from the catalog. On March 17, 2008, John Deere unveiled a prototype at ConExpo in Las Vegas, branding it a completely new machine form. This was the public debut of the 764 high-speed dozer, or HSD. By April 2009, the production model entered the commercial sales catalog, targeting contractors looking to streamline their fleets. The hybrid designation did not refer to an electric powertrain, but rather to a functional fusion of heavy equipment roles. Crawler dozers excelled at raw pushing force and low ground pressure flotation, while motor graders delivered rapid travel and fine surface control. John Deere product marketing manager Dan Drescher summarized the engineering vision as combining the speed of a grader with the flotation of a crawler dozer. By integrating these capabilities into a single platform, Deere aimed to reduce the need for multiple machines on a job site, offering a versatile alternative that could transition seamlessly from bulk earth moving to high-speed finish grading. According to John Deere's technical specifications, the 764 HSD is powered by a PowerTech 6068H 6-cylinder diesel engine. Standard manufacturer data sheets list the engine output at 200 gross horsepower, while official dealer brochures list 210 net horsepower at 1,800 RPM. This power plant moves a machine with a substantial operating weight, documented in Ritchie spec sheets at 33,999.7 pounds, though heavy-duty configuration listings with optional ballasts push that figure up to 38,000 pounds. In terms of dimensions, VeriTread shipping data shows a standard transport length of 22 feet 10 inches, a width over the tracks of 8.51 feet, and a height of 10.25 feet to the top of the cab. On the front end, the blade specifications show minor variations across official documentation. Ritchie specs registers an 11.1-foot blade width, whereas certain regional dealer brochures quote a 12-foot blade. Both sources agree on a 3.8 cubic yard capacity, a 7-degree blade swing in both directions, and a cutting depth of 29.1 inches. This blade work is powered by a hydraulic system with a pump flow rated at 73.8 gallons per minute, running through a 60-gallon reservoir under 6,650 pounds per square inch of relief valve pressure. The slight discrepancies in power, weight, and blade width across different literature sources are attributable to model year updates and regional configuration packages. Collectively, these physical dimensions establish the 764 HSD as a serious, full-scale production earth mover. Rather than dragging a rigid undercarriage through a turn like a standard dozer, the 764 HSD changes direction using a hydraulically actuated central articulation joint. This pivot allows the front and rear track sections to swing independently. During a turn, the hydrostatic system automatically varies the drive speeds of the inside and outside tracks to accommodate their differing paths. This active speed matching reduces ground scuffing and keeps the front moldboard aligned with the machine's direction of travel, improving grading control in tight spaces. Above the tracks, a cab-forward layout places the operator ahead of the engine mass. This design directly addresses the visibility limits of traditional crawler dozers. By positioning the operator directly over the work area, the machine delivers a documented all-around view of the blade and cutting edge. This uninterrupted sightline allows for faster blade corrections and increased operator precision at higher grading speeds. 4 independently suspended rubber track modules keep the chassis grounded, allowing each assembly to walk smoothly over uneven or bumpy surfaces. While official technical specifications claim a low ground pressure of 6.7 pounds per square inch, they also list a total ground contact area of just 1,272 square inches. This contact area figure does not mathematically align with an operating weight of 34,000 pounds, indicating a clear discrepancy in Deere's documentation. Beneath the frame, a hydrostatic drive continuously manages travel speed and load response. Rather than employing an add-on system, Deere integrated the main blade hydraulics directly into the core operator controls. The factory pre-wired the chassis for automatic grade control systems and installed a rear hitch with dual auxiliary hydraulic circuits for pulling scrapers, discs, or compactors. This platform relied on strategic component sharing, combining a crawler-derived powertrain and blade with a loader-derived cab, controls, and articulation, reducing development risk by utilizing established, high-volume product families. At the Union of Operating Engineers training facility in Wilmington, Illinois, instructor Kevin Zip Ackert put the machine to a practical test. Ackert resurfaced a 1,000-foot gravel road, spreading recycled asphalt over a soft, wet aggregate base with a 5% slope. Moving at a grading speed of 6 miles per hour, the machine finished the resurfacing in a single pass. During transport across the facility, the dozer reached travel speeds of 16 miles per hour. In separate commercial demonstrations, the unit reached 18 miles per hour across finished concrete without tearing up the pavement or requiring protective rubber mats. This run confirmed the machine could grade faster than a traditional crawler dozer and transit quickly between work areas. However, this single test did not prove the platform could entirely replace traditional motor graders or dedicated heavy dozers in every application. Instead, it established its viability for specific roles like site preparation, reclamation, and wet ground grading on active projects. While the machine achieved high speeds, fleet managers faced distinct operational realities. The articulated frame allowed tight turns, but rapid articulation caused the front blade to drift, demanding constant steering corrections. Combining dozer-style blade work with grader-like travel created a steep learning curve for operators. Positioned forward for improved visibility, the cab sat directly over the front powertrain, exposing the operator to increased noise and vibration. The independently suspended tracks minimized ground compaction, but introduced 4 separate undercarriage modules with additional shock absorbers, seals, and wear points. Hydrostatic travel and integrated auxiliary hydraulics increased the density of daily service points, while the rubber track suffered rapid wear on abrasive rock. Transport logistics remained a factor. The 34,000-pound machine still required a heavy-duty trailer despite its roading capabilities. Industry records diverge on when the 764 HSD left the market. Some commercial sources document production ending in 2010, while other equipment listings show the model available through 2012 before its eventual removal from Deere catalogs around 2015. No direct successor was ever introduced. At a reported list price of $330,000 and with no official sales figures published, the machine faced clear economic headwinds. Fleet owners remained loyal to separate grader and dozer classes, which Deere continued to support with dedicated high-volume product lines. The mechanical complexity and limited buyer base of this specialized hybrid struggled to achieve necessary economies of scale, leaving an unresolved question of whether market demand could ever sustain such a highly specialized design. Today, the 764 HSD remains a rare monument to compromise. Its legacy proves that on the job site, specialization still beats hybridization. Would you operate one? Share your thoughts below.